Welcome to this edition of the Designs for Health audio science article.
Nitric oxide. Say yes to NO. Nitric oxide, whose chemical formula and abbreviation are both NO, is a little gas with a lot of big jobs. After it was discovered that NO is essential for proper functioning of the brain, arteries, immune system, liver, pancreas, uterus, nerves, and lungs, the American Association for the Advancement of Science declared it the molecule of the year in 1992. Far from being what it was originally known as, a toxic compound found in smog, automobile exhaust, and cigarette smoke, it forms when nitrogen is burned, NO now claims a place as a key molecule for overall health, and for cardiovascular health in particular. In 1998, just 6 years after the spotlight was put on NO, 3 scientists shared a Nobel Peace Prize for their discoveries regarding NO as a signaling molecule in the cardiovascular system. Research on NO since then has only further solidified the importance of NO in human health. It plays a crucial role in the immune system as a toxic defense molecule against infectious organisms. It regulates the activity, growth, and death of a number of immune and inflammatory cell types, such as macrophages, T lymphocytes, antigen-presenting cells, mast cells, neutrophils, and natural killer cells. Nitric oxide is also a signaling molecule in the brain and the central nervous system. Glutamate, the most abundant excitatory neurotransmitter, initiates the reaction that forms nitric oxide. Much is not understood about the role of NO in the brain, but it appears to be a double-edged sword. It has some beneficial and protective effects, but excessive or abnormal production may be involved in neuronal cell death associated with neurodegenerative disorders such as Alzheimer's and Parkinson's diseases. There are 3 isoforms of NO synthase, or NOS, all of which require L-arginine and molecular oxygen as substrates, and also contain heme, making them iron-dependent as well. Neuronal NOS is expressed in central and peripheral neurons and select other cell types. It plays a role in the central nervous system's synaptic plasticity, central regulation of blood pressure, smooth muscle relaxation, and vasodilation. Inducible NOS is expressed in various cell types in response to lipopolysaccharide, cytokines, and other factors. The enzyme endothelial NOS, or eNOS, is expressed mostly in endothelial cells, where it facilitates blood vessel dilation, helps regulate blood pressure, and has other vasoprotective and anti-atherosclerotic effects. Moderate consumption of red wine is believed to be one of the health-promoting aspects of a Mediterranean diet, and to contribute to the French paradox, a population that consumes a high-saturated fat diet yet has low rates of cardiovascular disease. Setting aside for the moment that saturated fat is not harmful for the heart anyway, the effect of compounds in purple grapes on nitric oxide production may explain the supposed cardioprotective effects of red wine. Incubation of platelets with extracts from grape seeds and skin led to enhanced NO production and significant decreases in platelet aggregation. Incubation with extracts from both seeds and skin together had an additive effect, resulting in even greater inhibition of platelet aggregation, enhanced nitric oxide release, and reduced production of harmful superoxide free radicals. These findings echoed those of earlier research in which dietary flavonoids were shown to increase NO production. Platelets incubated with dilute purple grape juice showed enhanced release of platelet-derived nitric oxide, but we don't have to rely solely on in vitro data. Consumption of 7 milliliters per kilogram of purple grape juice daily for 14 days resulted in reduced platelet aggregation and increased platelet-derived nitric oxide production in 20 healthy subjects. Red wine is celebrated for its content of resveratrol, a polyphenol also found in peanuts. Resveratrol is a potent stimulator of the enzyme eNOS, which catalyzes the formation of nitric oxide in vascular endothelial cells. Resveratrol exerts a number of protective effects on the cardiovascular system in vitro via increased NO, such as inhibition of platelet aggregation and promotion of vasodilation. Impaired nitric oxide-dependent vasodilation is associated with increased risk of cardiovascular disease, so facilitating nitric oxide production may be helpful for supporting healthy cardiovascular function. The compound nitroglycerin acts by releasing NO gas, which underlies its medicinal use for chest pain. Resveratrol is not the only polyphenol capable of favorably affecting eNOS. Human umbilical vein endothelial cells treated with black currant juice concentrates showed increased activation of eNOS. Black currants are high in anthocyanins, flavonoid polyphenols that lend vegetables and fruits their red, blue, or purple pigments, such as those in blackberries and raspberries, red onions, plums, purple cabbage, and eggplant. Anthocyanins increase expression of endothelial nitric oxide synthase, or eNOS, and may additionally support healthy endothelial function because they're rich in antioxidants, and oxidative damage may interfere with endothelial cells' ability to produce nitric oxide. Vegetables are seemingly one of the only food groups almost all diet camps, vegetarian, paleo, Mediterranean, low-fat, and keto, can agree we should be eating plenty of. Red wine and purple grapes are only two examples of foods that may help influence nitric oxide synthesis. Vegetables rich in nitrates increase NO by way of the enterosalivary nitrate-nitrite-nitric oxide pathway. So it's not an old wives' tale that vegetables are good for the cardiovascular system. Vegetables high in nitrates, including celery, lettuce, beets, spinach, bok choy, endive, fennel, leeks, and parsley. A double-blind, placebo-controlled study of dietary nitrate in hypertensive adults found that 250 milliliters of beetroot juice taken daily for 4 weeks led to decreases in systolic and diastolic blood pressure compared to placebo, which used a nitrate-free beetroot juice. Endothelial function improved by 20%, and arterial stiffness was reduced in the nitrate group, with no changes seen in the nitrate-free group. For healthy cardiovascular function, doctors should tell their patients what mothers tell their children: eat your veggies.
Thanks for listening. For more excellent educational content, be sure to visit designsforhealth.com.